Hi everyone, so this is Tessa, and for today's video I'm going to share with you what I know about the test of independent means. Okay, so technically we used to call t-tests as test of differences because the research question that it answers is generally, is there a significant difference between two sets of groups or two sets of data. So in this series I'm going to discuss with you t-test of independent means and t-test of dependent means. Okay, so there is a difference between a very big difference on when to use t-test of independent means and t-test of dependent means. So let's start off with t-test of independent means. So t-test of independent means requires two groups. When we say groups, I always tell my students that the groupings should be established by, for example, the member of the other group cannot change his or her group easily. That's why they should have a common characteristic, or they should be it's not easy to change whether which group you belong. So a very good example is sex, which is male and female. Okay, no discrimination intended, but in statistics we actually use sex. It depends upon your research. As I've shared with my students before, if your research is concerned with gender, you use gender. But if your research is concerned with biological makeup, then you use sex. Okay, but it depends upon the institution that you belong to. Okay, now I have two groups here. I have section A and section B. So our research question can be established as, is there a significant difference between the performance of section A and section B? So in that case, we wanted to know if they are significantly different from each other. From the test itself, it says t-test of independent means. So we are going to test whether their means are independent from each other, or if they are statistically statistically similar. So if they are statistically similar, for those researchers that is using pre-test post-test research design, it's a very good it's a good sign to have them tested because it means that they are comparable. But for those who are standing alone with this test, we wanted to know actually if the two groups are very significant, or if they perform, or if the other section performed better than the other section. But if you're in STEM, you can use t-test of independent means by comparing groups of specimen, whether the other one outperforms the other group. Okay, so we have here data, and just click data analysis. Make sure that this is installed already in your Microsoft Excel, and you look for t-test of two sample. Yeah, so we have two examples here. So we have two sample assuming equal variances or equal dispersion of scores, and we have two sample assuming unequal variances. So for this example, we are going to use we assume that this two sets of groups have almost similar dispersion of scores. Okay, but it depends upon you. But in other statistical tools, they do not have these choices, so they just have t-test of independent means. Okay, so just click it, and another prompt window will be here. So you just have variable 1. So for variable 1, you choose section A. So just highlight it. Okay. Next. So for variable 2, you choose section B. Just highlight it. And you have, of course, we wanted to have the hypothesized mean difference as 0, or both of them are similar, statistically similar. And you check the labels because we have here the labels included. So now for the output range, let's just use this part. And if everything is already okay, depending on your preference, just click OK. And we have here the results. Okay, so we're going to discuss not just the computation but how to interpret this data. So we have the mean. Okay, so the mean is 6.52, and we have 7.28. So assuming that this is a test on a 10 item test, and we wanted to compare whether section A or section B outperforms the other one. So we also have the variance. More likely, you have here a higher mean but a higher dispersion. You have a lower mean but a lower standard deviation, a lower, what do you call this, a lower dispersion. Okay, so let's see. So we have 29 observation. So observations is actually your sample size. So if your teacher asks you what is the sample size of your set of data, you can just answer 29 times 2 because you have two groups. Okay, so that's actually 58. And we have pooled variance here and degrees of freedom. So let me just explain how degrees of freedom was computed. So that is n sub 1 plus n sub 2 minus 2. So that is 29 plus 29, which is 58 minus 2. So what is the use of degrees of freedom? So in technical terms or in practical use, we use it to locate the critical values or the t crit. For in this case, we have the critical value for t. Okay, but this is the number of, we call this, the degrees of freedom denotes the number of variables that are freely to change or free to be manipulated or adjusted, just like that. So we have here t-stat. So this is the computed t that we have. So t values do not have limitations on how big or how small your t value is. Okay, so depending on you, if you wanted to have a two-tailed test, then you just choose this one. If you wanted to have a one-tailed test, you choose this critical value. So as you can see, we have here p-value and we have two p-values. So depending on you. So for this example, I think we can use the two-tailed part. Okay, so for the two-tailed part, you have here this one first. So if you're going to compare this to this one, so this is both positive and negative. Okay, so that's positive 2.00 and negative 2.00. So if you're going to compare this one, if you're going to draw a normal curve and plot the points there, you will realize that negative 1.03 is inside the acceptance region. So when you have acceptance region, that is where we accept the null hypothesis. So what do we mean by this if we wanted to accept the null hypothesis? So if you wanted to accept the null hypothesis, then we can assume that these two sections here are comparable or their mean is statistically similar. Statistically similar but not numerically. So we already have the statistics there. So if you're going to report it, so you have section A and B are comparable groups. So you can have it just like that. The simplest interpretation that you can have, or you can just have there is no significant difference between the means of section A and B. Okay, so let's go back to the p-value. So if you're going to have the p-value there, we actually compare it with 0.05, 0.01, and 0.00. So if the p-value is actually less than 0.05, then it is significant at p less than 0.05. In senior high school, I think we still use the traditional one, which is t. But if you wanted to know more about p or p values, let me know in the comments below, and I'll try to make a video out of it. Okay, so but technically this is the same. So you will have the same interpretation as that critical value. But if you're still in senior high school and practicing practical research too, it's very important that you know first how to interpret using critical values. Okay, so you ask your teacher about the table, but if you wanted to, I can provide one table at the description below. Okay, now let's try using Soxai online statistics software or online application so that you can have choices, because not all people can have the data analysis function if your Microsoft Excel is 2007 and below. Okay, so let me just open the statistical website that we have. Okay, So we have your social science statistics, and let's have calculator. So just click on calculators. Then you look for Ttest. Okay, so we have your Ttest for two independent means and Ttest for dependent means. Of course, we are going to use two independent means. If you're going to ask me, when do we use independent means versus dependent means? If you have two groups and you wanted to know if these two groups are statistically similar or you can compare them, you use independent means, two groups. But when you have dependent means, you have two sets of data and you wanted to know whether this is the easiest way to differentiate them, whether the treatment is is effective. You can use dependent means because you're pertaining to one group and you're going to test this group twice or more than once. But for independent means, you have two groups and you're going to test them once only. Okay, so let's go to the test calculator. And you have here, you can just have, let us copy the values. Okay, and we have the second one. Of course, we will be expecting the same answer for this two. So we have 0.05 and we used two-tailed a while ago. Okay, so let's calculate T and P values. Okay, so you read this. Okay, so you read this part so that you will understand the meaning, but not really the meaning, but the essence of this test. Okay, because if you cannot understand, or if you cannot interpret the numbers, then the numbers or the computation will not have any meaning at all. Okay, so we have here, let's go to this part. So the value is negative 1.03, just like what we have in the Excel a while ago, and the p-value is 0.31, just like the Excel that we have a while ago. So the result is not significant at p less than 0.05. So you just have three choices there, three common choices, which is 0.05, 0.01, and 0.000. This is the lowest. If this is not significant at p less than 0.05, then it is not really significant. Okay, then we can just check how to report a t-test result using APA. So let me just check it. And this, you can just, let's have independent t-test. So you can have this copied as template, but not the values, of course. You can just make it as your reference so that you will not have any problems looking for a reliable template for your reporting in independent t-test. Okay, I think that's all for t-test of independent means. I'll just see you on the next video about t-test of dependent means. See you on the next video. Bye.